Okay, let's jump right into this explainer. Managing machine secrets across multi-cloud environments? It's honestly become a massive headache in modern cloud architecture. Today, we're benchmarking HashiCorp Vault head-to-head against Akeyless to figure out how to finally conquer secret sprawl. Because, look, achieving true zero-trust security shouldn't mean you have to sacrifice API performance or just completely drown in maintenance.
So you really got to ask yourself, is your current secret management strategy actually creating more work than it saves? We're starting with this because we need to know if getting that ultimate zero-trust security actually requires putting up with ultimate operational pain. Managing private key infrastructure is, frankly, a beast of a job. So the real question for us today is whether the modern SaaS alternative is actually secure enough. We're going to break down the architectural differences so you can decide if it's finally time to rethink those clusters.
Here's the roadmap for today. We're covering 1. The operational burden, 2. The SaaS alternative, 3. The dynamic secrets lifecycle, 4. High compliance governance, and 5. Strategic selection.
All right, let's hit Section 1, the operational burden.
When you look at the hidden labor costs of keeping HashiCorp Vault running smoothly in 2026, you're looking at some seriously heavy, complex manual processes. We're talking manual scaling across different cloud regions, constant patching to keep things secure, and dialing in incredibly complicated high-availability configurations. This is absolutely not a set-it-and-forget-it kind of deal. To maintain these clusters, you literally need dedicated, highly specialized people just to make sure your secret management doesn't completely bottleneck your growing infrastructure.
And honestly, the irony here is just wild. The operational weight of running these self-managed clusters can easily turn into a total nightmare. Because you know what happens when a security tool is too heavy and resource-intensive? Developers find workarounds. They always do. And those workarounds are exactly how you end up with dangerous secret sprawl, which actually weakens your security posture instead of strengthening it.
Which brings us right into Section 2, the SaaS alternative. Now, Akeyless comes at this from a totally different angle, using something called distributed fragments cryptography. Basically, it's a zero-knowledge architecture. This means it mathematically guarantees that Akeyless literally cannot access your secrets. Why? Because the encryption keys are fragmented. The service provider never ever holds the complete key. So you get all that sweet, frictionless onboarding of a SaaS product, but without just handing over the keys to the kingdom.
The contrast in deployment speed here is just staggering. Think about it. You are weighing weeks of maintenance, capacity planning, and cluster provisioning with Vault against instant, frictionless, API-driven provisioning with Akeyless. For teams that just need to move fast across complex multi-cloud environments, getting rid of that operational drag is a massive game changer.
Moving on to Section 3, the dynamic secrets lifecycle. If we want to move past the danger of static keys, we need dynamic secret injection. So we're digging deep into the high-stakes benchmarks here. We're looking at API response times for just-in-time credential generation across AWS, Azure, and Google Cloud. When you rely on dynamic secrets, meaning credentials spun up on the fly for a specific task, API performance is make or break. If it's too slow, your apps just time out. Now, both Vault and Akeyless perform exceptionally well here, but you really have to see how they benchmark in your specific ecosystem to make the right call.
The security payoff with this dynamic approach is absolutely huge. You're getting short-lived credentials that literally vanish after a task is done. They rotate automatically, with zero developer intervention required. That massively reduces the blast radius if a leak ever does happen. I mean, if an attacker intercepts a dynamic secret, it's probably already expired by the time they even try to use it.
All right, Section 4, high compliance governance.
This is where we hit a really stark architectural divide when it comes to rigorous auditing. Vault gives you unmatched granular local control and physical isolation. If your compliance mandate says, hey, secrets can never leave this specific physical server rack, Vault will execute that flawlessly. On the flip side, Akeyless leverages centralized policy engines for global compliance parity. It makes it incredibly simple to enforce rules across all your geographic regions right from a SaaS platform.
So it all boils down to this core trade-off, owning the entire security stack versus leveraging a managed service. You really have to weigh if your high-compliance environment actually requires the sheer complexity of owning the stack. Does your regulatory body absolutely demand Vault's physical isolation? Or can you trust the centralized, mathematically guaranteed SaaS approach of Akeyless?
And that leads us to our final part, Section 5, strategic selection.
Ultimately, this is a balancing act between a frictionless developer experience and non-negotiable zero-trust demands.
If you're a fast-moving startup that prioritizes agility above all else, the SaaS-native simplicity of Akeyless easily outweighs the heavy overhead of private infrastructure. But if you're a global bank with zero appetite for external service dependencies, well, Vault's self-managed clusters might just be mandatory for you.
When you zoom out and calculate the overarching benchmark over a 3-year total cost of ownership, things get really revealing. You can't just look at the upfront licensing costs. You absolutely have to factor in the hidden expenses. We're talking massive cloud egress fees from self-managed clusters talking to each other across regions, not to mention the very real salaries of the specialized engineers you need to maintain the whole shebang. So I'll leave you with this. Does your risk appetite demand self-managed clusters, or is a frictionless SaaS developer experience your true priority? Stop letting secret sprawl weaken your multi-cloud security. Look hard at your team's capabilities, your real compliance requirements, and your actual operational costs. Because at the end of the day, the right choice is the one your engineers will actually use. Thanks for hanging out with me for this explainer, and keep questioning how your architecture is truly working for you.